Today I'm talking about this specific heat capacity, and let's start it with an example. Let's say we have taken a vessel and it contains 1 kilogram water. This 1 kilogram water. Water is symbolized by S2O. It is 1 kg water. Okay, another vessel is also taken, and it contains 1 kilogram mercury. Mercury is symbol Hg. Shortly, I am writing Hg, and this is also 1 kilogram. And if we measure temperature of both of them, they are in the same environment. Let's say their temperature is 20 degrees Celsius. Both of them have same temperature. Now, I want to increase their temperature by 1 degree Celsius. It means finally I want it 21 degrees Celsius. When water is heated and mercury is heated, what is found practically? It is found that when water absorbs 4200 joule heat energy, then its temperature rises by 1 degree Celsius. But on the other hand, this mercury, when it absorbs 138 joule heat energy, then its temperature rises by 1 degree Celsius. Very interesting. One requires huge amount of heat energy to raise its temperature by 1 degree Celsius. Another requires less amount of heat energy to raise its temperature by 1 degree Celsius. In the same way, if it is left to decrease the temperature, I mean to say heat is removed from both of them, for 1 degree Celsius temperature, loss of temperature, what is found? Water loses 4200 joule heat energy and it again comes back to 20 degrees Celsius. And in the same way, from 21 degrees Celsius, when this mercury loses 138 joule heat energy, then its temperature falls down to again 20 degrees Celsius. It means this is very interesting matter, and this is named as, this term is created and this term is named as specific heat capacity. It can be defined this way. What is specific capacity? The amount of heat required to increase or decrease the temperature of 1 kilogram of a substance through 1 degree Celsius is called specific capacity of that substance. It means different substances have different specific capacity. Look at this is some information. Water. Now, specific capacity of water is told as 4200 joule per kg degree Celsius, and this joule per kg degree Celsius is the unit of specific capacity. In the same way, mercury's specific capacity is 138 joule per kg degree Celsius. But don't be confused, this joule per kg degree Celsius is exactly not SI unit. Joule is SI unit, kg is also according to SI unit, the mass is measured in kilogram, but degree Celsius is not SI unit, we use Kelvin. If we are asked to write the SI unit of specific capacity, then we have to write joule per kg Kelvin. Okay, now there are some other substances. Just for example, iron. Iron's specific capacity is 470 joule per kg degree Celsius. In the same way, paraffin. Paraffin wax or wax is specific capacity. Paraffin oil, it is called normally oil, Paraffin. Paraffin oil, its specific capacity is 2200 joule per kg degree Celsius. Now another one, just for example, sand. Its specific capacity is taken as 800 joule per kg degree Celsius. Now, looking at this value, it's very interesting. Different substances have different specific heat capacity. What should be the reason, or what is the reason behind this? Different objects are made up of, or different substances are made up of different matter. And different matter contains different types of molecules. The molecules are different. That's why specific heat capacity depends upon the nature of molecule of the substance. Hence, specific heat capacity of different substances is different. We can answer this way in the examination. Okay, this is about the specific heat capacity. Now, sometimes question may be like this also. Why specific heat capacity of water is 4200 joule per kg degree Celsius? What is the meaning of this saying? Now we can answer this way. 1 kilogram of water requires 4200 joule heat energy to increase or decrease its temperature by 1 degree Celsius. That's why its specific capacity is 4200 joule per kg degree Celsius. What is the meaning of the specific capacity of mercury is 138 joule per kg degree Celsius? We have to answer in the same way. 1 kilogram of, instead of saying water, mercury requires, instead of saying 4200 joule, 138 joule heat energy to increase or decrease its temperature by 1 degree Celsius. That's why its specific capacity is 138 joule per kg degree Celsius. This way we can answer this type of reason question also. Now another matter I want to focus here. A substance has high specific capacity, especially I'm talking about water. Water has very high specific capacity. How much? 4200 joule per kg degree Celsius. And mercury has very less specific capacity, 138 joule per kg degree Celsius in comparison with this. It means when we heat a little amount of water and same amount of mercury, then water takes very long time to be heated up. But mercury takes very short time to be heated up on heating. Why? The reason is very simple. For every 1 degree Celsius rise in temperature, water requires, if it is 1 kilogram, it requires 4200 joule heat energy to raise its temperature by 1 degree Celsius. And it requires just 138 joule heat energy to raise its temperature by 1 degree Celsius. That's why if both of them are heated to 100 degrees Celsius, then 100 times 138 joule heat energy is required to go from 0 degree Celsius to 100 degree Celsius. But here 100 into 4200 joule heat energy is required to go from 0 degree Celsius to 100 degree Celsius. It means a substance having high specific capacity takes very long time to be heated up on heating. But if a substance has less specific capacity, it takes very short time to be heated up. The reason is it requires less amount of heat energy. It requires high amount of heat energy to go up to the same temperature. Now another point, if both of them are cooled down from the same temperature, look at this. Now we are cooling them. If we left them to cool down by atmosphere, then what is seen? For every 1 degree Celsius fall in temperature for this water, it releases 4200 joule heat energy. If it takes 5 minutes to release 4200 joule heat energy by 1 kilogram of water, then its temperature falls down to 99 degrees Celsius. And from 100 degrees Celsius within 5 minutes, if this also in the same environment, it also loses 4200 joule heat energy, then roughly how many 138 is contained in 4200? Let's say 140, 14 3 42, means 30 degrees Celsius temperature will fall down. Its final temperature is around 70 degrees Celsius. Within 5 minutes, if both of them are cooled down, then its temperature falls down to just 99. Its temperature falls down to 70 degrees Celsius. What I mean to say, if a substance has high specific capacity, it takes long time to cool down. But if a substance has low specific capacity, it cools down very quickly, because release of less amount of heat energy also cools it down to low temperature. And this way we can describe the property of the substance having high specific capacity and low specific capacity also. Okay, this much for today. We'll continue in next class.